All right, so I wanted to go over a couple problems here with you guys. So if we're looking at here, number one, it's asking for domain and range. Okay, so remember this is what's called a discrete relation because there's spaces here. So when we say domain, we can't just use it from one number to the other. This is spaced out, so we got to be very selective and specific. So my domain are these x values. So there's an x value at 1. There's an x value at 2. There's an x value at 3. There's an x value at not 4, but 5 and 6. Okay, so what I did was I used set notation to individualize each number. We do the same thing with the range. So the range here is 1, 2, 4, and 5. So 1, 2, 4, and 5. And we don't care that there's more than one. Just, whatever the output is, you don't need to be redundant and label it again. And is it a function? Well, if we did the vertical line test, are there any 2 points that if I draw a vertical line, it would cross more than once? If you look here, that one doesn't pass the vertical line test. So we would say no. And the reason is because this input of 1 has more than one output. Okay, remember the definition of a function is for each input, there exists exactly one output. Okay, so do the same thing here for number 2. All right, this is discrete as well. Okay, and think about if you graph them, would it pass the vertical line test? Okay, and then I'm gonna do number 3 with you guys. So when you see this empty circle, that means you're gonna use a parenthesis because you're not including that point. But when it's filled in, you are including that point. And this here is continuous, so we can use all the numbers between. So we'll use not set notation, but interval notation, and we'll use either parentheses or brackets. Okay, so domain is from left to right, so it looks like it starts here and ends here. So it starts at 1, but we don't include 1 because it's empty. And then it goes to 2, 3, 4, 5, 6, but we include 6. So we're going to put a bracket there on 6. And then the same thing with the range. So there's nothing at 0, nothing at 1, but it starts at 2, but not including 2. And then it goes up to 4. And then we put a bracket there on 4 because it includes that point right there. It includes it. So that's the range. And then that's the domain. All of those. Okay, so try that on number 4. All right, so if you look at number 5, we've got, we're figuring out the f of whatever this is. So basically you're just plugging in what's there. Okay, that should be easy, the f of 2. You can do that. F of negative x, okay, we'll actually be doing this later on. So we got to get used to it. So we just plug in a negative x wherever there's an x. So this will be a negative x. So when I simplify a little bit, I get negative x over 1 plus x, which of course, I can leave it that way, or I like to put the negative right out there in front, like so. Okay, when you do this one, when you plug it in, don't forget to distribute the negative before you simplify. And I'm going to do 6a too. So I'm going to go ahead and plug in negative x. So if you look here and you were squaring negative x, it's negative x times negative x, which is positive x squared. So it actually turns it into a positive. and then a negative times a negative is a positive, so we end up with 2x squared plus x. Okay, you guys can do these. So you plug in x plus y here, x plus y there. Don't forget to square it. So when you square in a binomial, remember the trick is to square this one, multiply them together and double it, and then square that one. Okay, but I'm not going to ruin the fun for you guys. All right, so this one here, it's asking for g of 9. So you're just going to plug in 9 and simplify. Same thing here. You're going to plug in, such it's h of 64, you're going to plug in 64 and simplify. There is a cube root of 64. If you need to figure out what it is, use Desmos. Okay, but let's look at 10. So if I want to find f of x minus 5, okay, I'm going to plug in x minus 5 where there was an x, and everything else is the same. So this was x plus 5, but I'm plugging in x minus 5 where there was an x. Okay, so let's simplify a little bit. X minus 5 plus 5. Oh, I think I can actually write it smaller, because the minus 5 and the plus 5's cancel. We're left with just x. So it's just square root of x. That easy. You guys should be able to do these. F of 0, f of 1, f of negative 2. Okay, and then here it says, for what values is f of x equal to 0? So remember it's saying, when is y equal to 0? For what x values is y 0? It's just a fancy way of saying what are the x-intercepts, okay? So you might, have to guesstimate on some of them, do the best you can. And then it's asking for the domain and range on number 11. So how wide will it go and how high and low will it go? This should be actually really easy. Find the difference quotient, okay? So remember we're taking this and plugging it in here. So f of 1 plus h is going to be 2 times 1 plus h. Then you subtract f of 1, which is just plugging in 1, and then divide by h. Okay? So you're using this here and here. Okay, so let's look at 13, and then you guys can do 14 and 15. So f of 1 plus h. So that is 2 times 1 plus h. And then minus f of 1. Well, f of 1 is 2 times 1. And actually, I don't need that second set of parentheses. It's just on the other problems, you're going to have them in there. Make sure you put those parentheses there on the minus f of x, okay? Otherwise, you're going to get the answer wrong. And then this is all over h. So this is f of 1 plus h. This is f of 1. I'm going to distribute. So I get 2 plus 2h. And then minus 2 times 1, which is 2. All over h. These cancel. And you're left with 2h over h. The h's cancel, and you're left with 2. Okay, so you guys can do 14 and 15. Take your time. You should have more than enough time to do well on this because there's not that many problems left to do.